turn this recording from the right channel, so we are ready to go.
If I send you an email, can you help me with a firmware problem?
I can see if I can help, you know. And this is way too much. Did you guys see how the bar here went all the way up here when the door closed? Yep, that's how sensitive it is. A little bit too sensitive sometimes. Fortunately, I can control that a little bit, you know, just kind of lower the sensitivity a little bit. All right, so let's go ahead and get started. You know, so what I'll do today is to kind of finish up the operating system topic and then continue with the programming part, because I think the programming part is more important. The OS part is good, it's useful, but I think, you know, for the most part we know a lot of those concepts already. But I still have to finish it up because it is one of the topics in this class, so we have to finish that up. And it's book on CD. It's going to redo this every single time because until I fix the persistence problem, you know, this is not going to be going away. I guess I can just write a script.
Very good.
Have it do it automatically. It's not too bad. It's just minor inconvenience. All right. So this is, you know, the topic. This is the last chapter in the textbook that I will go with, at least for the time being. And then we'll switch to Scratch and talk about programming a little bit. You guys got some exposure last time, you know, with when I talked about Scratch. I know I did not write any notes, you know, and you know, but the recording is now online. So if you're new to programming, you might want to re-watch the video a little bit, because everything, I think with something like that, is better off with a video presentation than to do screenshots and then say, okay, drag this from here to here. Because, you know, in text, when it's static, when I say drag it from this place, and even if I indicate the location, you know, from where it's dragged from and to the location where you drag it to, sometimes it's really hard to convey, oh, but you have to drag it to between this block and this block. So it's really hard to specify the destination sometimes. So we're getting back to the discussion of operating systems. And I remember last time when we talked about operating systems, we ended up with the discussion of the history of DOS. Do you guys still remember, you know, how IBM contracted Microsoft for an operating system? It tried to buy CPM, and the owner of the CPM was not there. The wife said, you know, shoot, go away. And then Microsoft approached another company or another person who had a clone of CPM at the time, and that person decided to sell the clone of CPM to Microsoft, and Microsoft, you know, basically repackaged it to become Microsoft DOS, MS-DOS, and also PC-DOS. We also talked about the licensing, the importance of licensing, but this time it's not the licensing to individual users, but from one corporation to another corporation. Microsoft at the time was a really small company. Its most successful product at that time was probably AppleSoft Basic. Do you guys still remember? Do you know what an Apple II is? Okay, let me show you a picture of an Apple II computer, and then you will start to understand, you know, the history of everything, because I think that's actually important.
Very large piece of junk.
Well, at the time it is not. Okay, when people use specify Apple II, they use, you know, two I's, but the most famous, you know, way to specify is to use the closed square bracket and then the open square bracket, because that's how it was used when people specify Apple II as a computer. So let's see, news for Apple II. I think it doesn't quite understand, you know, Apple II in this case. But when you look at Apple Inc., you're bound to find Apple II as one of their products. The early years. Yep. No, that's not quite the one that I have. You know, yeah. I wish I had this version, because, you know, it would sell for a lot of money today. It's made out of plywood, and, you know, had, you know, the word Apple computer, you know, kind of basically carved or routed out of it.
That's fun crap.
Okay, let's see if we can find the references to the Apple II computer, which is right there. And that's the Apple II computer. Do you guys have any recollection of this, or have you seen this in a museum?
I've used them.
Museum, right?
No, I used them in elementary school.
You in elementary school?
Yeah.
Wow. Okay.
Yeah.
If you look at this, you would start to wonder, what is inside this thing here? What about these two?
Floppy drive.
The floppy disk drive. They're called full height floppy disk
huge.
drives. They are gigantic.
Gigantic.
They're gigantic, and initially they were all single-sided. In other words, they can only read one side of a floppy disk, but not the other one. So you would frequently, see a prompt from software to ask you to flip the disk, because it has, information stored on a double-sided floppy disk, but the floppy disk drive was single-sided. Okay, that's how ancient these things are. I think each side was only able to store about 180 kilobytes. That was the capacity of one side of a floppy disk. So when they first came out with a double-sided floppy disk, it sold like hotcakes. Because now people don't have to flip it anymore.
Now we can just get like 60 gigabyte drives, terabyte.
Yeah, well, the term terabyte existed at that time, but people thought it was so impractical, it was just impossible. Yep. So they
get a floppy disk like that.
Yeah, but
Yeah, big
remember,
one.
it wasn't that long ago. I mean, most of you would think, well, this must be really ancient, but it's not. It's 1977 or the late 70s. Okay, in human time frame, even within human time frame, that's not a lot of time. In other words, technology has progressed a lot in just how many years? 35 years. It's not really that much time to go from this kind of computer to the cell phones that we have. I mean, your cell phone can probably emulate or pretend to be an Apple II and probably have 20 emulation of Apple II computers without really taxing the processing power of your phone. This just reminds me to turn off my phone. There we go. I think that's pretty amazing. I mean, even working in the technology field for so long, I think the amount of progress we make over just 35 years is just amazing. Okay, but within this computer, how do you run programs, or what do you do with a computer like this? You can play games on this computer. Okay, I still remember there's a game called Falcon, the F-15 Strike Eagle. It was a flight simulation program. Okay, and it worked fairly well given the processing power of something like this. Can anyone imagine the processing power of this computer? It has a 1 megahertz 8-bit computer inside, processor inside. Forget about multi-core. This is way before we have multi-core processors. So it's one single processor, 1 megahertz, that's the clock speed of the processor. How does okay, you did not hear wrong, this is 1 megahertz, not 1 gigahertz, okay? Because by today's standard, if your PC is running at 1 gigahertz, something is wrong, okay? Because even the atoms run faster than 1 gigahertz now, okay? So this is running at 1 megahertz, which is 1,000th of a gigahertz, and it's an 8-bit processor. Every processor now, even on the atoms and just about anything, is at least a 32-bit processor, which means this computer will need four instructions to process to add an integer that we can process with one single instruction today. So that makes this really, really slow, because it's basically for any type of calculations, this will take about 4 times as long. For multiplication, is much worse than 4 times. It's about 16 times, right? And on this computer, if you want to write any program as an end user, you will have to write it in BASIC. And one of the BASIC interpreters back then was Apple's Soft BASIC, and it was a Microsoft product. And I think at the time, that was the most important Microsoft product until the PCs came along. So getting back to this part here, we're going to skip all the way to today's operating system. So we're having a little time warp here from 1977 to the present. when we use Windows today, which is a Microsoft product, which operating system do you think we're actually using? Because we talked about DOS, right? So do you think we're still using DOS, or do you think we're using something else today? It's not DOS anymore, okay? Because Microsoft reinvented the core operating system back in, I would say that's 19,
You're talking about when they added the
NT kernel.
That would have been XP was the first operating system.
Well, XP was
Ibm.
the first
Ibm.
available to consumers, but you know the NT kernel has been out for a while. You know, because
95.
sorry,
95. When the
95 or
first-
so?
when the
Okay.
first Windows server came out.
Yep, that's interesting because in 1995 or so we can actually just look it up. You know, it's pretty easy to look that up. And when you look for that, you want to look for OS2. Because OS2 is the precursor of the current NT kernel. Okay, this is the second time Microsoft and IBM kind of work together, and this time they work together and say, well, you know, we have all this fantastic hardware. The CPU is so much more capable than we are actually making use out of it. Let's go ahead and write a new operating system to make use of all the nice features of the processor at the time. Okay, so this is another example to illustrate how software is lagging behind hardware advances. Because the 386 processor has been out for a long, long time until they have an operating system that can actually make use of it. And this one started out in 1985. So in 1985, IBM and Microsoft signed a joint development agreement during that year, which is 1 year after Apple aired the Big Brother 1984 commercial during the Olympics. So IBM went ahead and once again worked together with Microsoft for the last time to work on another operating system. This one to be more advanced. What do you think prompted Microsoft and IBM to work on a new operating system? Because Windows was out already. Okay, Windows was out. The really early days. Windows 2.1, 3.1. I think those were out already at this time. So they have a GUI already. But what do you think was the problem? Was with these earlier versions of Windows, which actually persisted to Windows 95 and 98. Well, not OS2, but in Windows 95 and Windows 98, they had some problems that are really frustrating to end users. What do you think those problems were?
Was it if one program locked up the whole system?
Exactly.
Locked up?
The programs have to play really nice with each other because there was no policeman. Imagine a government that has no enforcement branch. That's DOS and early versions of Windows.
The kernel couldn't separate the programs out.
Exactly. There's no enforcement. Okay. Do you guys still remember how I compared the operating system to a government? Okay. So imagine a government that has no enforcement branch. There's no police. There are no courts. There are no nothing to enforce rules. They only post rules and say it would be nice if you guys play by these rules, but nobody's going to watch and enforce these rules. Okay, that's how it all worked in early days, with DOS and with all the early day Windows programs. In other words, in today's term, it means one application program can see the memory content of everybody else, including the operating system. And when you have multitasking, in other words, you start up one program, another program, and another program, these programs appear to run at the same time, but that's only because they are cooperating with each other. And I'll explain quickly how it works. So let's say we are the three programs running at the same time. You may be a browser, which did not come along until very late. Let's say you're a word processor, and I'm the file manager. Okay. So after I do a little bit of processing, maybe I want to list the content of a folder. So I'll do some processing, and then when it's time for me to say, oh, I think I used up a lot of processing time already, I'll stop and I'll give control to you. Okay, so you will do some processing with whatever processing you have to do, and then you have to voluntarily give up control to another program, and then you do some processing, and then you give control back to me. So we have to play nice. We cannot just hog the processor. What if I decide that I'll just hog the processing resources to, do all the sorting and all the searching within the folder?
Crash.
Well, it doesn't crash. You guys just don't get any processing resources at all. So the computer will appear to be quote unquote locked up because one program is hogging all the resources. But worse than that, I also have access to the memory content of all the other application programs. So if I misbehave, I can crash not only the file manager, I can crash everything else, including the operating system, and give you the blue screen of death. Yeah. So anything can cause the blue screen of death back in those days. Okay? And that's why, people were not happy with, Windows 95 and 98. It's because of the lack of protection of one application program from another application program. Even the operating system itself is not immune to misbehavior of its own application programs. Okay, how much memory do you think Windows 95 and 98 can handle? Not a whole lot. Okay, and the reason why it's not a whole lot, it's because Windows 95 and 98 could only make use of the 16-bit version of a 386 processor. So even though the processor itself was already capable of addressing up to 4 gigabytes of memory, it's still using the 32-bit processor as if it was a 16-bit processor. And it was only able to address up to 20 bits of addresses, which is I think 1 megabyte or so at the time. So that's why, at this time, between 85 and 88, IBM and Microsoft both decided that a new operating system is required. And then they started up, the development together, and eventually they broke up. Every time IBM had to deal with Microsoft, it always ended badly. Remember the first time, MS-DOS versus PC-DOS, which gave rise to all the competitor products?
But that breakup for this one in particular was good though, because OS2 really only supported IBM products.
Well, that was the intention. Was IBM will use OS2 for its products, and then Microsoft will use the NT kernel for its own products. But I think Microsoft got more out of this deal than IBM did. In other words, they put in both companies put in resources to develop the new operating system, but in the end, the IBM version was phased out quickly after the deal.
Microsoft retained the patents too.
Yep. So Microsoft got the really much better end of the stick in this case, just like the first time. So this is the new operating system, and it gave rise to. Let me switch back to here. It gave rise to Windows that we know of today. For consumers, Windows XP was the first operating system to make use of the kernel that was developed, starting from 1985. And it was a much better kernel because in this case, the operating system actually has ways to enforce rules. Let's say I'm an application program. Okay, I go through the memory space, and I go like, I like to go to that particular location and change that location to something else. If that location does not belong to me, the operating system plus the processor will enforce the rule and say, bad program, you cannot do that. Okay? What do you see as an end user when I did something like that? It's called a
respond.
no. There's a particular name for that. It's called a GPF. In early day Windows, it's called a general protection fault. So when you see a general protection fault, it can be many, many different reasons. But every time an application program misbehaves and try to access a resource that it's not supposed to, the operating system and the processor will enforce the rule and say, nope, you cannot do that. And as a result, application programs are now protected from each other, and the kernel, which is the core part of the operating system, is also protected from all the application programs. And therefore, it is more stable compared to early versions of Windows. Are we doing okay so far? Because I think I spew out a lot of kind of some semi-technical terms, but hopefully in a way that everybody can kind of relate to. In other words, the later day Windows has enforcement capabilities. They can basically go to an application and say, nope, you're doing something wrong. I'm sending you to jail, basically. There's enforcement now. So that's Windows. Mac OS 10 or Mac OS went through a similar history because the early day Mac OS or Mac operating systems did not have any enforcement capabilities either. They did not even have true multitasking capabilities. Even as late as '85, there was no ability to multitask correctly with Mac OS until Mac OS 10 came along. Mac OS 10, unlike Windows, did not have a completely rebuilt operating system. Apple decided to use BSD or Berkeley Standard Distribution, which is a branch of Linux, as the core part of the operating system. And I think that was a really smart decision, because now they don't have to rewrite an entire operating system nor to support the operating system, because another organization, BSD, is now responsible to keep the kernel or the core part of the operating system stable. Okay, but Apple did have to put up its own interface, its own graphical user interface on top of BSD, because otherwise, what do you think BSD will look like?
Thanks.
It's a little.
Thing for this, or will it?
This is all done by.
I think it's done by a program. So a program will take a video file, like a FLV or AVI file, and then the program will take that as the input, and then send the output through a text interface. And this is all done on the fly. If I change the resolution of the text screen, it will rescale everything on the fly and do it correctly.
Imagine if all that was done by hand. Imagine if all that was done by hand.
Yeah, I think that should be a little brighter pixel over here. Let's change that character.
Might still be working.
Yep. So that's that explains the history of Windows and Mac OS. So the Mac OS 10 that we see today is really BSD, which has a text interface, kind of primitive, but with a GUI on top of it. The GUI part is Apple's contribution, and that's proprietary. BSD itself is open source, but the graphical user interface on top of BSD is proprietary, and that's why you're still paying for upgrades to the next OS 10 version. Do you have to pay for that?
It's $20.
$20?
Yeah.
So it's not too bad.
No, not too bad.
But everything or most things that you learn in Linux will also apply to Mac OS 10. If you open up a terminal, most of the commands that we use in Linux or any type of Unix type operating system will work just as well in Mac OS 10.
I've seen that. I've seen that.
Yeah, but that's assuming Apple allows you to install certain type of apps and open up a terminal, because sometimes they lock it down, so you cannot do it. Okay, and here's Linux. Linux has a completely different history. So if you look up, if you want to find what is the history of Linux, I think Wikipedia actually has a really good history on Linux. So we just looked up Linux here, and it explains the history of Linux. Now Linux, by comparison, is actually a very new operating system, because when you look up the history of Linux, it says it's first released October 1st in 1991. So by comparison, this is actually pretty new. It's almost like the new kid on the block. The Linux operating system is a Unix look-alike operating system, but it's not a Unix operating system. For certain reasons, it was never classified as a Unix operating system. It got close, but not exactly the same. And it was, from the very get-go, it was developed as a free operating system for the x86 platform, but later on it was also cross-compiled to just any type of processor that people have. When people have new processor designs, a lot of times, even before the processor was fabricated, which means you have the actual hardware of the new processor, they can run certain things using an emulator. And many times, Linux will be the operating system available before the chip, even the first chip, is off the production line. And that's because because Linux is open sourced, That means anyone can look at the source code and say, oh, I want to make this work with my super duper new processor here. As long as you are willing to put in the work to make Linux work with a new processor, you can. You are allowed to. But Windows is proprietary. No one except for Microsoft has the source code to Windows. If Microsoft decides, I don't want to work with this new processor, then nobody can get Windows to work on the new processor. Does everybody understand that particular aspect of open source and how it really helps with hardware manufacturers? So it has since been ported, which means translated and modified to work with just about any computer hardware platforms. For those of you with an Android smartphone, Android has Linux as the core operating system. It has some other stuff on top of Linux, and that's why it's called Android. But underneath, it has Linux as the core operating system. Yep, go ahead.
You can actually, I know for tablets, I don't know if it'd be very usable on your phone, but you can get the Linux interface, like the graphical user interface, and like the full version of Linux. Like I think
some of the platforms allow you to do it. It depends on whether you can reflash the device or not. On phones, I would advise not to do it, because most phones have a very proprietary hardware, like for the cell phone part and the other stuff. So you might be able to run native Linux on it, but if it stops being a phone, then your phone is really not very useful anymore at that point. Yep. And when you look down this list here, okay, let me just kind of skip all the way to. I'm not going to find it. I'll just look for it. Okay, so I'm just I'm skipping a whole lot of stuff. I'm fast forwarding from 91 to 2008. And here it says some of the major corporations. Okay, I'm just going to highlight what I'm talking about here. So when in 2008, which is 17 years after 1991, it was not only supported by volunteers. A lot of big corporations like Dell, IBM, HP, Oracle, Sun, and so on, they started to contribute code to the Linux operating system, particularly IBM. Can anyone imagine why IBM and Linux are related? Remember the two, kind of not so pleasant dealing with Microsoft of IBM that we just talked about? One was DOS, and the other one was NT/OS2. Okay, IBM later on decided that it wants to use a well-supported operating system for its servers. So we are no longer talking about personal computers, because IBM decided not to stay in the personal computer market or industry. That was how many years ago? Maybe 5 years ago? 4 or 5 years ago. So IBM decided to get out of the personal computer market and focus only on their servers. And IBM chose Linux as one of the offering as the operating system on their servers. And why do you think IBM would do that?
they can change it themselves.
It's open source, okay? So if they want to, they can put in their own changes or make sure that the operating system is secure. But if they license Windows or some other proprietary operating system, they cannot do that, okay? So that's one good reason. What about the other reasons? How much resources do you think Microsoft has to spend to maintain, update, upgrade, and debug the Windows operating system? Okay, I'll give you 3 choices. Nothing. They don't have to spend any money on it. They have to spend a lot of money on it. Or they can spend just a little bit of money. They're spending a lot of money, okay? They're spending a lot of money because besides Microsoft Corporation, Incorporated, who else has the source code to Windows? Nobody. And without the source code to a particular program, you cannot make any changes. You cannot even inspect it for security problems. You cannot inspect it for stability problems. So nobody except for Microsoft can help Microsoft in this case because the operating system is proprietary. What about Linux? It's an open source product, which means anyone, including you guys, if you want to, you can look at the source code of Linux and you can say, well, I'm a security expert and I think this particular approach of doing things will expose certain important parts of the operating system. So what do you think is responsible, or who is paying for the maintenance and upkeep of Linux? Whoever finds it useful, okay? That's basically the point. Whoever finds it useful. IBM finds it useful, they can contribute their code, they can contribute time to make Linux a even more stable and more secure operating system. Yep, go ahead, Hiroshi. Thank you. Thanks for the reminder. Start to this side. And HP, thought basically the same way, because before this, IBM had its own operating system on its servers called AIX, and HP had their own operating system called HP UX, which is the Unix of HP, and both corporations thought it's actually more cost effective to use Linux and just put in enough effort to keep Linux as an secure operating system and keep it up to date for their servers. Any questions about this? Okay. Has anyone heard of the lawsuit between, what is the company? I'm trying to remember the company that sued IBM and a whole bunch of other companies for using Linux because they think they own the license of some of the code that is used inside Linux.
Microsoft.
No, it's not Microsoft, but it is. But people have found a money trail going back to Microsoft. So Microsoft was funding a much smaller company to sue all these other companies using Linux. And this wasn't that long ago either. I think that was maybe 7 or 8 years ago. Nobody remember the whole thing? No? I don't even remember any clues of the name of the company. Otherwise, okay, I can try to look for this. Sue, and I think the auto supply company called AutoZone. Okay, AutoZone Linux. I think that should be enough. SCO, that's it. Okay, this article is outdated, but nonetheless, it is an interesting story. This is in 2007, so that was 5 years ago, not 7 years ago. So 5 years ago, SCO, Santa Cruz Operations, Santa Cruz Operation Group decided to sue anyone using Linux. Well, the reason why they're suing people using Linux but not suing Linux itself is because there's no such thing as Linux itself. It's not a particular organization, creating the source code or maintaining the source code. It's all distributed. So they cannot sue whoever is writing the code for Linux, but they can sue the people using Linux as an operating system. So they were suing everybody. They were suing Novell, they were suing IBM, and they were suing car manufacturers. Okay, AutoZone, which is a supply company, the back end of that company was running on a Linux server. And so they're using Linux, and SCO went after them. I think there were some other companies like Chrysler and Mercedes-Benz. They were also using Linux, as a back-end server, for their operations. And those companies got sued too. And if you read the rest of this, story, it's really long, so I'm not going to read the whole thing. But basically, the whole thing was, considered as, it's a scam. Okay, it's basically a scam to try to scare people not to use Linux. Okay, and this was back when Bill Gates, basically openly talked about Linux and called it a virus, and it's an attack on capitalism. Da 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 da. And later on, I think Microsoft as a corporation had toned down considerably and basically accepted open source as a product or as a different philosophy, and it can actually benefit from open source products. So you can go ahead and read all this fun stuff here if you are interested in the history of all these different operating systems and all these corporations and organizations that are of how they relate to each other. So getting back to this slide here, are we doing okay so far? DOS was one of the original operating systems, but it was actually a clone of something else. It gave rise to Windows, but Windows basically reinvented itself, in 85, between 85 and 90, it reinvented itself, and today, the Windows that we use actually have no relationship to DOS anymore, except for conventions, especially useless and annoying conventions. What do you think is one of those, really annoying conventions that make Linux people really crazy when they use DOS or Windows?
Different syntax.
Different syntax is one, but there's one particularly annoying to me.
It's Windows.
Well, when you name your files, Linux is case sensitive. So uppercase, ABC is considered different from lowercase abc. But DOS was not. Now remember, DOS was a really old product. It came from the 70s, okay? So it's kind of understandable why, back then people only need 8 characters for their file name, 3 characters for the extension, and have no case sensitivity. But because that was the core of the early day Windows, okay? So when Windows was reinvented, when the Windows kernel was reinvented in between 85 and 90, they decided to keep that convention. So even to date, Windows is case insensitive when you name files. Hmm? And that causes a lot of problems for people who use Linux, because a lot of times, we make the file extension case sensitive, and those programs do not work well in Windows. Mac OS is case sensitive because it is Unix, basically at the core. Are we doing okay so far with the history of these operating systems? What about the other side? What about the purple stuff? Well, first of all, do you think the purple stuff is actually separate on their own? Or do you think they're actually related to Windows, Mac OS, Unix, Linux, and DOS?
Yeah,
They're all related, okay? I think with the only exception of Palm OS, which was completely, its own thing, all of the other tablet type operating systems are related to their sibling or their, heritage on the other side. Android is related to what? It's related to Linux. HP Web OS, which is kind of, why do we even talk about it today? But it is related to Linux as well. iOS is related to Mac OS. How about Symbian?
DOS.
I think Symbian was related to Unix too.
About Chrome.
Hmm?
Doesn't Google name
Chrome is basically dressed up Linux.
Yeah.
So when you get a Chromebook, you are actually running Linux. You're running Linux, as the underlying operating system, but Google, also has its, quote unquote proprietary interface on top of it. So it looks different from, the Linux I'm using right now, but underneath it is all Linux. Okay. I'm not sure about BlackBerry, because BlackBerry is, the original BlackBerry operating system is actually its own thing. And then BlackBerry purchased a company called QNX. QNX makes a Unix type operating system that is really modularized and is really secure. Can anyone imagine what is the application of the QNX operating system? It's small, it is efficient, it is extremely stable. So where do you think you will find deployment of the QNX operating system? Servers of all kinds, nuclear plants. Nuclear plants in the United States, or at least several of the nuclear plants, use QNX as an operating system. And BlackBerry, for some reason, bought the entire company, the QNX company. And I think they had plans to use the QNX operating system on their handheld devices, but the company could never really act on it, at least not in time. And then Android and iOS was gaining momentum at the time already, So I think BlackBerry just lost out the entire market share because of the inability to act on something, when it is important to act on it. Is BlackBerry still going as a company?
Yes.
Are they still healthy?
No, barely.
Yeah, but
They're on life support.
They're on life support.
They just released the BlackBerry OS 10 with phones that are actually full touchscreen
Okay.
just recently.
That's probably QNX based. That's after they do the purchase of a QNX. What about Nokia?
Life support.
Life support, right? And Nokia had a new friend called, which company was the new best friend of Nokia?
Windows.
Microsoft, exactly. Okay, so those two companies work together and say, well, together we can push, Windows, the mobile version of Windows on phones. Yep, go ahead.
BlackBerry OS is related to Java.
Related to Java, but Java is just a programming language.
Java virtual machine. is
But
what its
underneath the
kernel
virtual
package.
machine, it still needs an operating system.
That's what Wikipedia lists as its kernel package.
Okay.
Java virtual machine.
Wow. So it's a native Java virtual machine, which has its pluses and minuses. Now this Android OS is also programmable in Java, so BlackBerry is also Java based. How many people have heard of the word Java in the context of programming and computer stuff? You can raise your hand. I mean,
If you have a Windows computer, you see it every day when you're getting it.
But what exactly is Java? It is related to operating systems, but it's kind of there and not quite there. Okay, can anyone tell me what Java is? Because Java is many things.
Code.
part of the GUI.
Okay, you're both correct. Some more. There's more answers to it. Java is.
Program
I
that
already
runs
mentioned that
scripts.
word earlier. Go ahead.
A program that runs specific, multiple scripts.
Okay,
on
it's a
web
programming
page.
language. Okay, I think that's what you were getting at. I also mentioned a word called virtual machine, and that's also what Java is. Okay, so Java is all of those things.
Java is also the one that gets corrupted.
Sorry?
I said Java is also the one that gets easily corrupted.
It depends on the implementation. Okay, so I'll just kind of spend a little bit of time to talk about what Java is, because it is actually related to the context that we are talking about here. Java is many things. Okay, the first thing that it is a programming language. Okay, let's spell it out. Programming language. As a programming language, it has a lot of resemblance to C and C++. So for those of you who are on track in our computer science degree, you can actually take a class. It's CISP 401, on this campus, and it's Java programming. So Java is a programming language. It has a lot of resemblance to C and C++. If you know how to program in C or C++, you already know like 80% of the language of Java. So that's what it is too, okay? This is one aspect of Java. Okay, so when you program in Java, okay, you have a program that ends with the extension of Java. Okay, so we'll just call this xyz.java. And this program is just basically a text file that you can read and you can edit. But the computer has no idea whatsoever how to deal with this program. It's just a text file. Remember, the computer, the processor, only understands, instructions specified in long strings of zeros and ones that are completely cryptic to the rest of us. So this program or this file means nothing whatsoever to the processor. My i7 processor has no idea of what to do with this file. So the next thing you have to do with a file like this is to go through what we call a compilation, and the compilation process will give you another file. Sometimes it's a jar file. Jar stands for Java Archive, but this time this is basically instructions. Cannot spell instructions. Instructions. Machine instructions. Okay, so when you look at a jar file, sometimes when you go through your file system, you may find jar files, depending on what programs you're looking at. But this jar file has instructions for machines. But the interesting part about this is it is not instructions intended for any particular hardware machines. In other words, it's not instructions intended for my Android phone, which uses an ARM core processor. It's not instruction intended for the i386 or the i7, the i5 processors. It's not intended for any particular processor. That's interesting. So when you have a jar file, the next thing you have to go through is what we call a Java virtual machine. Virtual machine VM is right here. So this is actually what I would consider as the core of Java, is the virtual machine. So the virtual machine will take in a jar file, and then it will translate whatever is specified in a jar file to instructions that can be natively executed by your processor, by the hardware processor. So from here, it will be translated into i386, which is basically the Intel architecture. It can translate to the ARM architecture. It can translate to a variety of architectures so that these processors can execute instructions natively in order to run the program specified in a jar file. Okay. Are there any questions at this point?
Why all the trouble?
Why all the trouble? Very good. Okay. Well, this is not the entire story yet, okay? Because in this process, okay, before it gets here, well, you know, I would say, okay, I'll do it here. The other thing is it can also interact directly with an operating system. The operating system here can be Windows, can be Mac OS X, can be Linux, okay? And going through the processor, it will also translate to instructions that can execute on these processors natively. So the question, that's a good question. Why do we go through all this trouble? Oh, there's one more thing here. It can also talk to the GUI of a particular environment. So, you know, from the GUI part, you know, you can have Android, you can have Mac OS X, you can also have Windows. That's the GUI part. In other words, the Java virtual machine is the hub of everything. Okay, it talks to the operating system to get to the files, to get to other resources. It gets to the GUI to interact with the user, and it also executes instructions, you know, to a variety of platforms in the backend. Yep.
That's why there's all the trouble.
That's why it has troubles, and that's.
Well, I mean, I'm saying that's why all the trouble, to answer the question, because it can do all those things.
Mm-hmm.
It's
It has access. It's cross-platform. It can potentially have access to everything on your computer, but it also has one huge advantage. What do you think is the big one huge advantage here?
Works on everything.
It works on everything, exactly. When it does work, it works on everything. Okay, I can show you a
It's
program.
also its biggest disadvantage, though, too.
Yep, it can be a strength, it can be a disadvantage. It all depends on how you look at it. Remember that I showed you, I think it's under Office, FreeMind. Some of you remember, you know, I showed you this program. Okay. So I'm going to use this program, which is a Java application, to illustrate, you know, Java itself. Okay, so we have Java. So we'll talk about the pros on one hand, and we'll talk about the cons on the other hand. The pros on one hand is one application, one source, work on everything. Because it doesn't matter whether the back end has an Intel processor, or an ARM processor, or any future processors that we don't even know yet. It doesn't matter which operating system you're running. You can be running Windows, you can be running Mac OS X, you can be running Linux. It doesn't matter what GUI or what graphical user interface you're using. It can be Mac OS X, Windows, or any of the Windows manager in Linux. You only have to write the Java program XYZ once. It can do everything after that. It doesn't matter which operating system you're using. Your program, specified as, you know, a Java program, can present the same user interface. It can go to the network the same way. It can do everything exactly the same way. There are very, very few differences between operating systems that will actually have to make a difference when you specify the source code. So from the developer's perspective, this has a lot of attraction. Because as a developer, whether you want to sell the software or you're basically a contracted developer who has to develop the software for a particular client, it doesn't matter, because as long as your program can work on a variety of machines, the actual hardware, you don't have to rewrite the program at all when your client decides, oh, guess what, we are switching from PCs to Mac, computers. Makes no difference. Oh, guess what, we are changing again from Mac OS 10 computers to Linux computers. Doesn't make any difference.
It's completely backward compatible.
It's also has a very long history of backward compatibility, yes, which is something that Visual Basic programs cannot say. Okay, so this is one huge advantage of one source works on everything. What do you think would be some of the cons of this approach? Look at all the arrows. How many arrows do we have? We have 1, 2, and then we have a whole bunch of arrows here. Okay?
Less efficient.
Sorry?
Less efficient.
Less efficient. Exactly.
A lot of
Okay?
resources needed.
Something goes wrong, there's a lot more to go.
Something goes wrong, there's more to go wrong.
Like if there's a problem with a certain part of the code.
Okay. All right. So one flaw for all platforms, right? If the virtual machine itself has a flaw, then that flaw will be present on every single platform. But you can also see the advantage, because FreeMind itself, what I'm using right here, is a Java program. So this program will work in Linux, which is what I'm showing you right now. But if you have Mac OS 10, you can download FreeMind, it works the same way. If you have Windows, you can download it, it works the same way. Okay? And that's one huge advantage of Java. Now there are other advantages too that I cannot really go into as much. It has automatic memory management. Remember how we talked about memory leak and stuff like that? So in theory, Java programs should not have memory leak, because it has what we call automatic garbage collection. In other words, when something is not needed anymore, there's a mechanism to basically recycle the memory that these particular things are using. So that is supposed to be automatic. And there are a few more cons here. Not a free language. Which company owns the right to Java?
Oracle.
It used to be Sun Microsystem. Sun Microsystem was somewhat protective of Java as a programming language and also as an environment. Even though it was not charging other people money or licensing to use it, it was still very protective and say, no, you cannot tell me what to do with Java. I'm not going to add that feature. I'm going to add this feature instead. So it was dictating the development of Java. But now the Oracle took over Sun Microsystem, and as the new owner of Java, what do you think Oracle is doing with it? What's one of the first things that Oracle did after the acquisition of Sun Microsystem? And this relates to Google. Oracle was suing Google for using Java on Android. That was one of the first things they did after the acquisition of Sun Microsystem. For the many, many years that Sun Microsystem had Java, it never even thought about suing Google. As soon as Oracle took over, it's like, oh, Google, you're in big trouble now because I'm going to sue you. You are using Java. I think you're using the same mechanism of garbage collection, which is patented. Okay, and that's how that's basically the technical reason that Oracle was suing basically Android, but Android belongs to Google Group. So that's how these two giants are fighting. I think it's still ongoing. I don't think it's settled. Yep. Where do you think we'll find Java? Where do we find Java?
Everywhere.
Well, according to the advertisement of Java, everywhere. right?
Yeah.
And it really is kind of everywhere. Okay, let's go ahead and take a look at some of these things. Okay, desktop apps. I mean, you're looking at a desktop application running on Java right now. Okay, so we know that part is true. What else can you find Java?
Web pages.
Hmm?
Web pages.
Web pages, okay? So for web scripts, okay, web scripts. And it's a big thing too, that's why that's why most people want to learn Java, is to write applications, web applications in Java. Where else can you find Java?
Mobile devices.
Mobile devices, okay? So particularly Android devices, and also according to what you guys told me earlier, BlackBerry.
Games as well.
Games, okay. But we are missing something that I think is actually even more cool than these things that we have listed so far. I'm not kidding.
Really?
Really. One of the Mars rovers, had its application written in Java, and the extension, the rover was only supposed to last so long on Mars, and because of the stability of software, the ability to upgrade the software, and also the reliability of the hardware, it ran, I think, a long time after its quote unquote shelf life after landing on Mars. Yep. Yeah, if the programs were written in C and C++, it can easily have memory leak, and eventually, it will run out of memory. And upgrading and changing the program is not as easy as with Java programs. Java programs tend to be more modular. You can change one module without making impacts to everything else. Okay, so Java is interesting because it connects everything. It connects to the GUI, it connects to the operating system, and it also connects to a variety of processes on the other side. But on the other end, when you are a developer, when you write the programs, you only have to write it once. There's one more thing that I forgot to mention here. Where do we find Java? Something that we did in the previous class period. Scratch. Okay? Now Scratch, when you save a Scratch project and you publish it over at scratch.mit.edu, it becomes a Java application. And that's why Scratch applications can run on any platform. As long as you have Java installed, you can actually go to scratch.mit.edu and play with the applications written by other people. That's one of the apps, I think, one of the Scratch apps. So are we understanding why Java is actually related to what we are talking about? Because it makes the differences between operating systems and graphical user interfaces, it dissolves the differences. It doesn't make a difference anymore. Which also helps to bring up the next point. In the next 10 years, okay, what do you think would be the value of this picture? From the end user's perspective. It will all be one single bubble.
Yeah.
Okay? Because end users will not care about the operating system anymore. In about 10 years, not today, but in about 10 years. Why do you think I say that?
It'll be on the cloud.
Hmm?
It'll be on the cloud.
It'll be on the cloud, exactly. It will be on the cloud, which means not only is your data saved in the cloud, but the app will also be running in the cloud as well. I can give you one quick demonstration of what I mean by that. I've done this already in the past, but I think it is a good point to bring it up again. Okay, so you go to Google, and I have to remember to sign in. Now Google is in the cloud, and when I go to Drive, I can create a document. Okay, it doesn't even matter what I'm doing here. Okay, so I can type a document. This is a test document. Okay. And I can do most of the things, well, many of the things, I wouldn't say most, but I can do many of the things that I can do with a desktop word processor. in 10 years, I can imagine that an application like this will be mature enough that it can handle 95% of what you need from a word processor. Okay? Can I run this in, now this is running Linux with a particular graphical user interface. Can I run this in Windows?
Sure.
Can I run it in Windows using Firefox, Internet Explorer, Chrome?
Yes.
What about Opera? It'll run in all those browsers, right? Will this run on Mac OS 10? In Safari, in Firefox, Google Chrome? Will this run on your cell phone? Yeah, to a certain extent, yes.
Actually,
Yep.
I have their Safari will do it. It will actually do everything that you can do on here. And then there are certain multiple app programs, and even Google has like apps that
Mhm.
will run this on the phone.
Yep.
So
Yep. So this makes, this even dwarfs, Java, because even with Java, what do you think these things are all running? Are they running on your device, or is this running remotely on the cloud? This is all running on your own device, right? In other words, the jar file still has to be downloaded onto your machine in order for a Java virtual machine installed on your machine to execute the program, to run the program. That's all being run on the other side. It's all being run in the cloud. So comparing this approach, the cloud-based approach, compared to the Java approach, the cloud-based approach is even better because it is not only is it operating system independent, it is also browser independent. And that's why Chrome OS only has basically a browser, because that's all you need. Yep.
Isn't it dangerous? Because whoever controls the cloud controls everything pretty
That
much. And
is
it
true.
is just, so easy to destroy the whole system.
That's true. Well, that's a very good point to make, because the government, always hesitates to go to the cloud, because when we think about the cloud, when we think of the cloud, what are we thinking of? Who owns the cloud? Who runs the cloud? Okay, Google has its own cloud. Amazon has its own cloud. Okay, I think I pointed this up, in a few classes. Okay, so when you look up AWS of Amazon, this is their Amazon Web Services, and it's basically cloud-based, and you can own a piece of the cloud. In other words, you can pay money to have resources in this particular cloud. Okay. In other words, yes, you are absolutely right. Amazon has control over your appliance running in the cloud. Google has control over your documents stored in the cloud. But what makes you think that you cannot have your own cloud? Yep.
this is kind of a funny conversation. I wonder how many people that have this concern that also do online shopping, because you're
I don't.
okay.
Never.
Never.
But the people who some people who have the same concern
Mhm.
willingly give companies like Amazon like their credit card numbers. I mean, even my credit card
It's
numbers.
convenience, right?
Yeah.
Yep.
And so like you're saying my documents. What about your financial information and your personal information and all that stuff that you've already given? If you have a cell phone, if you have a Google email account, if you
Mhm.
have any online account at all, even Facebook,
Yep.
you've already given the cloud more information than your documents have.
Yep.
Because you've given your personal information to include your address, in some cases your social security number, your birthday. You've given them enough information to steal your identity already. So
agree.
that
Yep.
concern is kind of null if you're already using internet services.
Well, but let's say there is a valid concern, okay? Because you have not you have to watch Summer Wars, the anime that I was recommending, because that's a projection of the future where everybody store not only their documents but also their passwords, on the web. So now, if an AI can hack into your accounts, it can also get the passwords, to get into all the other resources. So I'm going to change this picture a little bit. This is not going to be in the quiz, so don't have to worry about this part. Okay, so the question is, can you own a piece of the cloud? That's the question. Okay, because you want to store your own documents in a secure way, and you don't want anybody else to have the ability to access your stuff, right? Hmm?
If you host it, wouldn't you be running it that you'd be responsible for the
That is
security?
correct. You can host it. Now, today, if you want to host your own server, you have to like what you did. You have to install your operating system. You have to install the application in the box, and so on and so forth. But what if? Okay, I need a little prop here. Okay, this is a good one. What if? What if Google says, okay, for $20 a month, I will lease you a box like this, okay?
It's a wonderful
Probably
box.
and probably with a different logo, because Disney will have a problem with that. So Google says you can lease a box for $20 a month, and all you have to do is to take this box home, plug it into the wall outlet, plug it in, not even plug it to your Wi-Fi. You can just configure your Wi-Fi, and you can have your own security. Your own security. You are allowed to use some other means, other than using Google, to generate a key pair encryption. Okay, so that way, this is your box, but it is also internet visible if you want to make it internet visible. So that means when you go to Google Docs, you're going to myname.drive.google.com, and that connects to your own box. When you type your document, it is stored in this box, but encrypted in a way that only you can decipher.
What if you stop paying?
What if you stop paying?
Paying them, will they have access to it?
Well, they will still have, they might have, because you might want to have your content backed up too. Because what if someone breaks into your house and say, oh, I like your Darth Vader little box here, I'm going to take it away. Well, they can take your box away, but your data should be backed up by Google, by some other company. Now, whoever backs up your data can only back up the encrypted file. They can look at the encrypted version of the file, which is just gibberish. You are the only person with a deciphering key to unlock the content. So if you decide not to pay Google, they will take the box back, okay, until you want to pay again. But when you're ready to pay $20 a month again, you can get another box, probably an upgraded one, and they can restore the content into the box, and you still will have your content back. Yep.
Well, this came up whenever Google Docs first became a service before Drive.
Right.
Okay, and like people were like, Google can keep your data and all this other stuff. But like Google came out and said, our privacy practices specifically state that your data is your data and we will not keep it.
Mm-hmm.
So like even if you stop paying, the files that are maintained on their system are still yours. They cannot do anything with them.
Well, they do certain things with your email. If you have been exchanging email with a family member or friend about traveling to Florida, suddenly the ad that pops up will be airfare, low airfare to Florida.
That's Google Analytics though.
Yeah. Mm-hmm.
Totally different.
Yep. Well, kind of different, but not entirely different. I would say they still have access to the content of your documents. And the concern is, what are they going to do? I mean, they can change the company policy, or worse yet, someone can hack into their system. So it's not even Google's intention that is on the table right now. It is what if people have access to it? And the answer to it would be encryption keys, so that only you can decipher the content. So even Google doesn't know what you're doesn't know what I'm typing here, because when it's stored on the other end, it's going to be encrypted. So there are ways to get around, the issue about, the security of the cloud, because it doesn't have to be owned by Google or Amazon or any company, because you can have a piece of the cloud yourself as well. Okay. Are there any questions about this? In other words, in this particular textbook, New Perspective on Computer Concepts, by the time it gets to 2023, this entire chapter, I think, will be gone. Do you guys think that would be the case? Yep.
It might be there for historical purposes.
Well, for historical purposes, the book will just get thicker and thicker.
Yeah, that's true.
Yep, because it just get piled up, higher and higher in terms of historical stuff. So we'll go ahead and kind of move forward and scan all the way. See, there's a timeline here. This is really kind of interesting. So NT came out in '93, even though the development started in Do you guys still remember in the previous slides? 85. Yeah. So the development of NT, okay, I talked about this part here, it started in 1985, but it was 1993 when they actually released it, for actual use. That's how long it took to develop a brand new operating system. And that's why IBM just decided, I'm not going to maintain my own operating system anymore. I'm just going to use Linux. It's maintained by a community of people. Whoever finds it useful can chip in and put in the time. Okay. This is so it's an interesting timeline, and we talked about many aspects of this timeline. XP was the first operating system using the 32-bit kernel. And how much time was between 2001, which is XP, the release of XP, and the initial development phase of the NT kernel, between 85 and 2001. We're talking about 16 years here. So it took 16 years from the beginning of a programming project, a major programming project, to the point it is stable enough for consumer products to use it. 16 years. How long do you think was the hardware available to do all the stuff that you could do in Windows XP? Before 85. Okay, so the hardware was ready way before software was ready. What does that tell you about job opportunities and stuff like that?
Developers are needed.
Developers are needed. They're actually more needed than hardware engineers.
Not for gaming.
Sorry?
Not gaming.
Especially gaming. Especially
I
gaming.
have like 5 or 6 friends that can't get jobs as programmers. Cannot get a job.
In which field in programming?
In the gaming industry. It's
In the gaming-
oversaturated for programmers. They need 3D artists in the gaming industry more than anything.
And also game control, or game design, storyline, editing,
Story developing and graphic artists.
character development.
Yeah.
It's in other words, the gaming industry is becoming more like the movie industry. Okay, well, that's another shift that we are experiencing. Back in the Apple II days, what do you think is the most important talent when a game is developed? Character development? No, because you don't have the processing power, the resources to have quote-unquote characters. What about the AI? Forget about the AI. There's no such thing as an AI when you have a 1 megahertz processor and it's only 8-bit, and you only have 32 kilobytes of RAM too. Okay? What about graphics artists?
Nope.
When your screen only has 200 something pixels by 100 something pixels, there are only so many things you can do with that many pixels. How about 3D artists? What are you talking about 3D, right? There's no such thing as 3D back in those times. So the most important talent back in those days was the developer, who could write this program entirely in assembly programming language. Okay, that's the most important talent, because the processing resources is like this much, but you want to do this much with only that much resources. So the programmer becomes the most important part. What about today?
Artists.
The artists, okay? Story development, basically the non-technical skills are now becoming more important than the technical skills, or at least as important. Okay, so that's also a shift that is happening over time, and I think in the next 10 years the shift will continue. In other words, you will see in games, the importance of the producer, the importance of character design, character development, voice acting, and everything else will overshadow the importance of the technical stuff. Yep.
What I think is funny too for like programmers is that like most companies either look for or highly like seek people who have cloud certification. Like not just you're able to program a language, but you're also able to do solutions for the cloud because of the way everything is going.
Yep.
So you can't just be a programmer anymore and get a job. You have to, have certain certifications to be marketable.
Yep. Well, we're looking at fusion of different technologies, and that's only going to accelerate. We still have about 2 minutes or so. So if you are to become let's say you are really interested in the gaming industry and you want to kind of focus on the technical end, is there still anything else to do on the technical side of gaming? And if so, what do you think is the challenge now with the physical or the technical side of gaming?
Bug testing. Bug testing, like troubleshooting problems.
Troubleshooting problems, okay. But in terms of the hardware, what makes a game realistic?
Building the engine.
Building the engine, and how about the physics engine? What do you mean? What do I mean by the physics engine of a game? Yep.
The physics engine controls how your character and other objects in the world interact with each other.
Basically, objects, right? Exactly. So if you roll a tank, over, let's say, a tree branch, okay. In the old games, the tree branch will always break exactly the same way. It's just replaying a sequence that was pre-recorded, or it doesn't break at all if it is not supposed to be a breakable object. But now, with the physics engine, if you want to spend the resources on modeling how a tree branch should break when it's rolled over by other objects, you can actually make it realistic enough. So the tree branch can have a certain amount of, say, flexibility. So if you roll over it with a bicycle, it would just flex and bounce back. But if you roll over it with a hard object like a tank or really heavy, it would just flatten it, or it would just react differently. Yep.
Well, object interaction is also now trajectory based too. So like you were saying, the tree falls one direction. Now, depending on what angle you hit the tree at, depends on the angle that it falls. And it doesn't always fall at the same angle even if you hit it from the same angle.
So this is just for objects falling and stuff like that. What about the sound effect of objects interacting in the game?
Positional object.
Okay, is that realistic now? In other words, if someone were to fire a gun inside a room, do you hear the echo of the sound? You do? So is it actually physically modeled, or is it just replaying a certain sequence?
A little bit of both.
What I'm saying is, if you fire, if you make anything that has sound, let's say clapping, okay? If you stand in the middle of a room, a virtual room, and you clap, do you hear the same echo pattern as when you step all the way back in the room, at the back of a room?
Well, like
Probably or probably not.
Probably not yet.
Not yet, okay? So there are still work to be done with modeling the physics in objects in the game. Because that takes a lot of processing resources. We're talking about tracking the pressure wave of sound waves and see how we interact with objects inside the room, the walls, the ceiling, the floor. Because some objects will absorb the sound and some objects will basically bounce it back in different ways.
If you want to see where the future of graphics is going in games, look up something called Unity Heaven. It's a live render, like that the engine actually does live rendering instead of like
Pre-render.
It's all live rendering.
Yep.
There's tessellation, which is just instead of being all flat surfaces, there's actual like texture to the surface. Of rocks.
So that means I cannot play that game in the text window anymore.
Right.
You're gonna get the same.
It just won't feel the same. All right, I'll see you guys on Thursday. Oh, by the way, homework 3 is out already. So I made the due date on Wednesday.
Yeah, I have a friend and a couple other friends who are programmers. And they get good jobs, but like my friend who is a graphic artist, he had 7 job offers in the last week. And yeah, because you gotta think, the old school, like the new, like people who've been in the industry for a long time, graphic artists just do like programming. So which one? The top one.
The bottom one.
The bottom?
Yeah.
Alright, sir. My first chapter test, this is probably an issue with other people. We were sent through a couple attempts, and I had 2 attempts, and it's just not listed in Google and the grades. I was just wondering what's going on with that.
Okay. I cannot look up your name here because otherwise you never need to see it. It's the first one?
Yeah, it's just
The first chapter? Okay, I'll have to take a look at it again. I can also have it regraded. Oh, one more thing is if you did not press submit all and finish, it can store all your answers, but it's not submitted for grading. I can go in and submit everything. I think on my end I have an option to submit it for you. If not, I can just open it up so you can start again. And I can close it.
I took chapter 3 last night, and
It said that it was finished, and I don't know the answers, but it didn't give me like.
Right, because
a
I
grade or
made it
anything.
kind of more like a real quiz, so the answers won't be disclosed until after the deadline is over. So it's a little different from the first two.
Will it still show you? It still doesn't show you how much, like,
Right, because
how much, like how well you did on the quiz.
I can release that, so I can open that up a little bit.
Actually, you kind of want to know if you need to retake
Yeah,
it.
yeah, exactly. That's the
okay.
thing is I don't know if
Yeah.
I
I'm gonna
understand.
take it or anything.
Okay.
That's fine with me. I mean, it's not in the grades, and it's not allowing you to review it.
Yeah.
Okay.
Like I don't care if I don't see the answers as long as I
kind of know how you did.
What's the
how I
score?
did.
Yeah.
Okay.
Okay, that'd be cool.
That'd be awesome.
Okay. Yeah, that would help. What? Thank you. What's your name? Philip.
See you later, sir.
You want to present?
Yeah. Final roll. Did you ever? You got it updated. Did you ever update it?
Update roll.
I know you mentioned you had to update your roll sheet after the first exam.
Yeah, I think from the number of leftover blank exams, I think a number of people have dropped the class already.
Yeah.
I can stop the recording of the previous.